No, I'm recording. All right. So on here, solve for the unknown value. Leave answer as a simplified radical. No decimals. So on here, we really shouldn't have to have a calculator for this if we're going to simplify a radical and do no decimal. So how am I going to solve for the missing side? Pythagorean theorem, yeah. So I got 7 squared equals 5 squared plus my unknown side, which was z squared. 7 squared is 49. 5 squared is 25. Subtract off 25 from 49, and you're left with 24. Good. And then we're doing the square root of that to get z by itself. So square root of 24, that can reduce, 2 square root of 6, because the biggest perfect square that goes into 24 is 4. Right? 4 times 6 gives you 24. Square root of 4 is 2, so 2 radical 6. Again, does not require a calculator. Make sure you show your work, too, tomorrow, because, again, if you don't get to the correct answer, but you have most of that work correct, you'll get most of the points. So make sure you show your work. All right, number 2. We have 4, we have 8, we're missing W. Again, plug into Pythagorean theorem. Jaden, could you do me a favor and close that door? There's a lot of noise coming in from outside. He wanted to get on the recording. All right, so we got W squared equals 4 squared, which is 16. 8 squared is 64. Add those two together and you get 80. So now we need the square root of 80. Biggest square root, biggest perfect square that goes into 80 is 16. So 16 times what gives you 80? 5, yes. So we have the square root of 16 times 5. Square root of 16 is 4. So we have 4 radical 5. That's our answer. Yep. Number 3. Jessica is building a fence around her yard. They sell fence by the foot. If her yard is in the shape of a right triangle and the two legs are 9 and 11, how much fence will she need to buy to fence in the garden? So again, we have a right triangle. It told us these two are the legs. In order to find the hypotenuse, we're going to use Pythagorean theorem again. So we need, I'm going to just call it x. X squared equals 9 squared plus 11 squared. So now, squared equals 21 plus 121. 81 plus 121? 202, yeah. So now, we have x squared is equal to 202. Biggest perfect square that goes into 202. I'm having trouble thinking of a perfect square for 202. 49. What'd you get?
I said 49.5, but
okay, so I got 2.
Wow, I'm drawing blanks here. And is that just a bad number? Divided by 4, no. Divided by 9, no. 16, no. I don't think there's a good number that goes into that. I think that's it. So, nope. Square root of 202. Now, can I leave out square root of 202?
Yes.
No. What does it say in the directions? Round to nearest whole foot. I actually need a number here. So let's use our calculator this time. What is the square root of 202? 14.2. All right. So now, question. Is my answer 14? No, why not? The next whole foot, why wouldn't I want to just do 14? It's not the next whole foot. Now, normally if we were to round this up, it'd round down to 14. Why can't we round down in this scenario? Yeah, we won't cover the whole garden. We can't buy less than what we need. So we need at least 14.2. If we buy 14 feet, we won't have enough fence. So we got to round up to 15 feet. Wait, that was inches. I need one of those is feet. You can put FT as well. Whatever. 15 feet. All right.
the entire garden. So then 35.
Oh, thank you. 15 is going to be for that side. You have to add that 15 to the other two pieces. I almost forgot to do that. So 15 plus 9 plus 11 is a total of 35. Sorry. 35 is the final answer. 35 feet. All right. Thanks for catching that. All right. On the next part, given the lengths of the segments, what type of triangle can be formed? So first off, go through and check to see, can it form a triangle? So is 5, 8, and 12. If I add those two together, it's 13, so it's more than 12. So that one can make a triangle. So I'm going to go through and first double check these. All right, the two smaller ones here, 5 and 9. If I add those two up, that's 14. That's more than 11, so it makes a triangle. 2 and 4, that's 6. That's not more than 8. That one doesn't make a triangle. So this one, not a triangle. The other two, I can plug into Pythagorean theorem and see what type of triangle they are. So 12 squared equals 5 squared plus 8 squared. 12 squared is 144. 5 squared is 25. 8 squared is 64. 25 plus 64? 89. That's not any bigger than that. This one's bigger. So it's obtuse. C squared value is greater than the rest of it. Therefore, it's obtuse. All right. On the next one, 11 is the biggest value. So that's our C. 9 and 5 going in for A and B. 11 squared, 121. 9 squared, 81. 5 squared, 25. 81 plus 25. 81 plus 25. 106. Right? Yeah. Sorry, I didn't hear the whole number at first. So we got 121. Oh, this one again is... How would we have got a right triangle if they were equal? And how would we get an acute triangle if we had a less than symbol? All right. So, moving on. Up here, a couple more. So now, is this
Wait. Slow down again. Wait, come on. Okay, never mind. Sorry.
All right. These two up here. Is this one a triangle? No. Why not? So 5 and 8 are equal to 13, not greater than 13. So this is not a triangle. All right. 9, 12, and 15. Wait a minute. Does anybody recognize those?
Yeah.
It was a triple. That's our 3, 4, 5, all multiplied by 3, right? If you can recognize it as a triple, do you even need to plug it into Pythagorean theorem? No. If you did plug it into Pythagorean theorem, what would happen? It would come out equal, and we know it's a right triangle. But if you recognize it as a triple, you can just write right triangle. You don't have to do the work. All right. If you did do the work, though, I promise it comes out and it works. So this would have been 225. This would have been 81, 144, and 225 equals 225, if we were to show the work. Number 9. What if the side of an equilateral triangle is 21 centimeters? What is the height of the triangle? So we did a couple problems like this from our book. When we had an equilateral triangle, and we drew in a height, it split it into two what type of triangles? Right, what type of right triangles? Not isosceles. All these angles started off as 60, right? So now this top one is 30. It's a 30, 60, 90 right triangle. The original sides were 21. All right? So first, split that in half for this side. So that's 21 over 2. 10.5. All right? And then this side, the height would be that 10.5 times radical 3. And that's it. We don't have any work to do here. Again, it's just our 30, 60, 90 properties. You got to have them memorized. Again, I will put those properties on the board for tomorrow, and that part of the test will be on Monday since we're short on time tomorrow. Yeah.
Okay, is this the review like similar to the test?
I mean, all these different types of questions are on the test, yes.
Okay, because like, I know the last time I took a test, I'm not gonna make the review like.
You were in here like when I did these, right? Just now.
No, I wasn't.
Okay, all right. So I think that's the only thing that's not. Again, there are some questions that are word problems on the test. We've done a few word problems, right? As Bell works. So, and we had one word problem on here, but there are a few word problems as well. But nothing on anything that we haven't already done. If the perimeter of a square is 24 inches, what is the length of the diagonal? So, this is a different way to ask this question, but we have a square. We have 24 for the entire perimeter. So, we know all these sides are the same, right? So, what is each one of these sides going to be? 6. Again, this was the entire perimeter, right? So, now all of them are 6. If I draw a diagonal in, what type of triangles are these? Isosceles right triangles, or 45, 45, 90s. If we know that the leg of a 45, 45, 90 is 6, the hypotenuse, which is our diagonal, will be what? 6 radical 2. Again, is there any work to do there? Not really. Drawing a picture, though, it helps. So draw your pictures. All right. Now, if you didn't remember that, could you have figured it out? Yes. Now, a question like this might be something that's on a non-calculator part, right? But again, do you need a calculator to do that? No. You just plug in the Pythagorean theorem, and you can solve it. So, remember our 45, 45, 90? All right. So these are our legs of our 45, 45, 90. So our hypotenuse is our leg times radical 2. That's all we did. All right. All right. On 11, again, 45, 45, 90. If that's 12, then A is 12. And B would be? No. 12 times radical 2. All right. Go to number 12. If the hypotenuse is 6, then C is 3. Our long leg would then be 3 radical 3. Again, is there any work there? No. All right, go on to the next one. This one, we have, and again, 30, 60, 90. We know this long leg is 9. We got to go backwards, and our long leg did not have the radical 3 on it. So you have to divide by radical 3. So this, if you want to show your work, 9 divided by radical 3. What ends up happening, though? You'll end up dividing by the number that's underneath the radical and multiplying by the same radical. So this ends up as 3 radical 3. Now, if you don't know how to do that without showing work, then you have to show how you rationalize the denominator. You multiply both the bottom and top by radical 3. So the top becomes 9 radical 3, the bottom becomes 3, and it becomes 3 radical 3. Again, that's your work for this, is your work for this answer right here. Don't want you to get that confused. All right, so that's 3 radical 3. The hypotenuse is what compared to the short leg? Double. So multiply that by 2. 6 radical 3. That's it. What is the value of G? Again, got to go backwards. So we're dividing by square root of 2. Again, if you follow the pattern, what ends up happening is you divide by 2 and multiply by radical 2. So this would just be 8 radical 2. Again, if you know the pattern, is there any work to actually show? No. If you don't remember the pattern, again, just remember, you're dividing by the square root of 2, and then you have to rationalize. So if you're going to show work, this would be your work. That's it. All right, moving on. Number 15. Yeah, you need it for a second? There you go.
Wait. So what's the answer?
8 radical 2.
I did these all like so much different. Because I did like Pythagorean theorem for all of them.
Again, could you solve this using Pythagorean theorem? Yeah, you could, but you need a calculator. Is that going to be on the calculator part of the test?
Yes.
No. And really, actually, you could probably do that with the calculator. Here, watch. If you had, let's see. I'm going to use a sticky note here. I don't want to take too much time on this. But if you want to do this with Pythagorean theorem, it can be solved. G squared plus G squared. Oh, I normally write it over here. 16 squared, right? I'm not going to touch that 16 squared just yet. All right. Do I? No, I need to. What is 16 squared? 256. All right. So then, these two, well, that'd be 2 times G squared would be another way of looking at that, right? So then, what's half of 256? So divide that by 2. 128 would equal G squared. And then you can square root that. Square root of that is going to give you G. Biggest number that goes into 128 is 64. It's the biggest perfect square. 64 times 2. Square root of 64 is 8. 8 radical 2 is G. Again, could you use Pythagorean theorem? Yeah. Does it take a little longer? Yeah, because you're supposed to know the properties of a 45, 45, 90 triangle. So you shouldn't have to do that. If you have to do this, you might run out of time on the test. Again, there'll be plenty of special right triangles. There'll also be a few places where you can use Pythagorean triples on the test to make it work faster. So you should know your triples. Hey, speaking of triples, look, there's one. Right? On a problem like this, do you think you'll be given all the values? Probably not. All right, what's sine of A? 12 over 13. Would this be on a calculator or non-calculator part, you think? So, yeah, non-calculator. There's nothing to plug into a calculator here, right? So now, cosine of A. 5 over 13. The adjacent side over the hypotenuse. Tangent of A. Opposite over adjacent. So, 12 over 5. Again, remember, sine. So, SOHCAHTOA, right? TOA. Sine's equal to opposite over hypotenuse. Cosine's equal to adjacent over hypotenuse. Tangent's equal to opposite over adjacent. I will put that up tomorrow since I'm going to give you the memorization part on Monday. Again, Monday you'd have to know that, right? So you should know that. It'll save you time if you know it, but you shouldn't have to look at it every single time. All right. I'm just saying it'll save you time if you have it memorized. On number 15, set up a ratio to solve for P, but do not evaluate. So, we want to solve for P. We're given this angle right here. What parts do we have? Well, P is our hypotenuse. 6 would be what compared to this side? Adjacent or opposite? Adjacent, because it's next to it. Which one of these things uses adjacent and hypotenuse? Cosine. So, cosine of our angle equals 6 over P. Now, do we need to solve anything? No. So, do you think this would be on a calculator or non-calculator part of the test? All right. Moving on. On number 16. All right, we got to solve this time. So, we're given a triangle similar as what we did in the last one, right? But now we actually have to solve. So, we have this angle. X is opposite. 12 is adjacent. Which one am I going to use? Sine, cosine, or tangent? Tangent. That's opposite and adjacent. So, tangent of 32 equals x over 12. Multiply the 12 to the other side. Yep. So, 12 times tangent of 32 will equal x. We got to plug this into the calculator. So, this would be on the calculator part of the test. There's no way to do this problem without a calculator. 12 times tangent of 32. 7.4984 blah blah blah. Round to nearest hundredth. Well, the hundredth I'd have to round up for that, so then it'd actually round to the 10th place. 7.5. That's still an approximation though. 7.5. All right. On the next one, now we're finding a degree. So we're going to have to use our inverse function. So on here, we're looking for this angle. Set up our equation first. This is our hypotenuse. 26 is our opposite, right? Opposite of hypotenuse is sine. So sine of f equals 26 over 32. In order to get f by itself, again, we're solving for an angle. This is where you do the inverse function. So inverse of sine of 26 over 32. Inverse sine of 26 over 32. Whoops, I typed that in wrong. 32 equals 54.34 blah blah blah. Round to nearest degree. So this is 54 degrees. Final answer. Now, again, that would be on the calculator part, right? For the next one, round to the hundredths place. Again, if it's saying round to a decimal place, will it be on the calculator or non-calculator part? The calculator part. If it didn't have those rounding directions and it says exact values, most likely it'll be on the non-calculator. It could have those instructions though on the calculator as well. All right. Number 18, round to nearest hundredth. So again, here we got two sides. Compared to that angle, this is our hypotenuse and our adjacent. So that's which one again? Cosine. So cosine of 64 equals W over 7. We just need to multiply the 7 to the other side. Plug it into your calculator. Cosine of 64 equals 3.0685. And it keeps going. What are we rounding to? Hundredth. So this is going to round up. 3.07 will be our final answer. All right. Last one. On 19, round to nearest tenth. Again, using that angle, this is opposite. This is hypotenuse. So I'm going to do sine. Sine of 48 equals 6 over k. I got k out of the denominator. But it's not by itself this time after multiplying. I got to do an extra step. What am I going to do with sine of 48? Divide it off. So k equals 6 over sine of 48. So 6 divided by sine of 48 is 8.07. And so round to the nearest tenth, so that'd be 8.1. Now, I did that whole worksheet, right? Question, on those last 1, 2, 3, 4, 5, on those last 5 questions, if your calculator is 9-degree mode, would you have got any of those answers right? No. So when you do the calculator portion of the test, first thing you should check is the mode. Make sure you're in degree mode. All right. If you're not in degree mode, you're going to get a lot wrong. So check your calculators. All right. I will post the answer to the other part online, as well as everything I just recorded.